Hello everyone. In this video, we are going to discuss the evaporation losses, that is a type of the reservoir loss, and how do we measure it. So let's start. So what are the different types of the reservoir losses? That will be the point of discussion, and then we will see what are the evaporation losses and how can we reduce them. So generally, huge quantity of water is lost from an impounding reservoir due to these three factors. That is because of the evaporation, because of absorption, and because of the percolation. And obviously, on the name of these three, we are having these three losses. That is the evaporation losses, the absorption losses, and the percolation, which is also known as the reservoir leakage. So first one will be the evaporation losses. Evaporation is basically a process to convert from the liquid state of matter to the gaseous state. So when the water which is impounded in the reservoir, if that is exposed to the certain amount of the temperature, and usually that is because of the sunlight, so certain amount of that water is lost in the form of the water vapors to the atmosphere, and that loss is known as the evaporation loss. So that loss depend upon the several factors such as the water surface area. So if the exposed surface area, if that is higher, then obviously the water which will be heated up, that will be higher, and because of that the water that will be lost, that will also be higher. Then the water depth, if the deep of water or the reservoir is deeper, then the losses corresponding to that will be lesser in comparison to the shallower reservoirs. Then humidity, that will dictate the temperature terms. Then wind velocity, if the wind velocity is more, then it would not allow to have a huge blanket of the water vapors above the reservoir, and that will quickly move it aside. Then the temperature, obviously that is a major factor. If the temperature is more, the evaporation will be more. Then the atmospheric pressure and the quality of the water. If the water is contaminated, if the water is salty, then there will be lesser chances of the evaporation. Now the evaporation loss from a reservoir under the given atmospheric condition is estimated by measuring the standard pan evaporation and multiplying the same value by the pan coefficient, because we cannot measure that how much reduction in the water has occurred for a particular reservoir, because it is not easy to measure the entire volume of that water. So what we do, we make a similarity with the atmospheric condition with the help of the particular pan, and that pan is placed, that standard pan for the evaporation is placed alongside of the reservoir. Now that pan is having a diameter of 120.7 centimeters, in which the height of that pan is kept as 25 centimeters. But that is not entirely filled, and the water is allowed to have the 5 to 7.5 centimeter from the rim, and it is placed on a platform which is 15 centimeter high. So the pan coefficient and various type of pan in case of the uses are, that is the class A pan. The most of the times what we do, we are having these pan for different geographical conditions, and corresponding to that we are having the different pan coefficients. Now whatever is the loss that we are obtaining for this particular pan, that is multiplied with the pan coefficient to obtain the loss of the water from the reservoir. So this class A pen, that is used in the United States of America, and the range for the pan coefficient that is from 0.6 to 0.8, and the average value that we take, that will be 0.7. Now on the basis of this only, in India we use this modified version. That means the certain dimensions are changed, and that is known as the modified class A pen, that is the Indian standard pen, and is used in India. That value of pen coefficient is 0.64 to 1.1, and corresponding to this the average value is taken as 0.8. And then we are having Colorado sunken pen, that is again for a particular catchment area for which we are obtaining this pen, and the value that varies from 0.75 to 0.86, and the average value is taken as 0.78. So all of these coefficients are used for different geographical condition. Now this class A pen and the Colorado sunken pen, these two are made up of the GI sheets, while the modified class A pen, which is used in India, that is using the copper sheet. So that is the basic difference between these different type of the pens. They are used in the different geographical conditions, and corresponding to that we will be having this reservoir evaporation, that will be equal to the pan coefficient into the pan evaporation. So if we are having the evaporation from the pan as 10 centimeter corresponding to the modified class A pan for the Indian conditions, so for that the average coefficient value is 0.8. So that means from the reservoir the evaporation loss will be 8 centimeter. That is how we measure the evaporation loss. Now these evaporation losses that we are having, they become very significant in the hot and humid country like India, because most of the time the temperature is very high, and therefore the realistic estimation of these losses is quite important. So these losses, they vary from place to place and from season to season. For different region, for different place, the value of this loss will be vary, and corresponding to the different months of the year, this value will be different. Now if we look at the one example, that the review which was conducted on the 130 reservoirs by the Central Water Commission in 1990, it estimated that the average annual evaporation loss is 225 centimeter. And if we collect and if we combine that for the all of the reservoirs that were taken for the sampling, then that will be 27,000 million cubic meter per annum. That means every year we are losing out this much amount of the water to the atmosphere. What a tremendous waste of the precious water. An object which is becoming scarce day by day, we are losing that out to the atmosphere. So to control such large scale wastages of the water, several methods have been devised by the engineers and the scientists. All of these methods, what they do, they are making an effort to reduce the evaporation rate from the surface of the water body by physical or the chemical means, because otherwise the other factor which control the evaporation process are the meteorological factors, and they are not in our hands, so they cannot be controlled under the normal conditions. So what we are having, the methods for the evaporation control are the windbreakers. That means if we provide the certain windbreakers in the near vicinity to the reservoir, then what will happen, that will reduce the wind velocity, and because of that the water vapor blanket which is accumulated above the reservoir, that would not be removed easily. Then the second of the method can be the providing the cover on the water surface. So if the water is not exposed to the temperature, then obviously the evaporation losses will be lesser. That is the second of the method. Next is the reduction of the exposed water surface. So there are different solar panels or the other type of objects which can be provided which can reduce the exposed water surface area. Then the use of the underground storage rather than the use of the surface storage, that can be another way. Then integrated operation of the reservoirs, that means if we are having the reservoir in such a way that that is frequently used and frequently filled up, that would result in the lesser evaporation losses. And the most effective method is the use of chemicals for retarding the evaporation rate from the reservoir surface. Most of these methods are self-explanatory, but the most frequently and most economically used method is the use of chemicals. So that we will discuss. So out of all of these methods that we have discussed, the use of chemical method that has evoked the maximum response, and that is considered to be the only practical solution for the conservation of the fresh water, in spite of its various limitations and disadvantages. Now, the use of these chemicals, they are known as the water evaporetardants, that is VERs. Now, for controlling the evaporation rate from the surface of the reservoir, we cannot use the toxic chemical. So that means the chemical that we are using, that must be non-toxic, and it should form a thin monomolecular film over the water surface. Now, this chemical can be used either in powder form or in the liquid form or in the emulsion form, whichever is available, and usually spread over the reservoir water surface. Now what it does, it prevents the energy inputs from the atmosphere. And when we are talking about the energy inputs, that means it is preventing the sun rays to attack to the atmosphere. It is preventing these sun rays to attack to the water surface and thus reducing the evaporation. Now such film, however, it allows the passage of the enough air through it and to avoid any harmful effect on the aquatic life due to the shortage of the oxygen. So if we are having enough air through it, so that means there will be no impact on the respiration process of the aquatic life which is living below this layer. Now what are the different chemicals that we can use? So the most frequently used chemicals are the cetyl alcohol, which is C16H33OH and also known as the hexadecanol. And the second of the chemical that is majorly used is the sterile alcohol, that is C15H37OH and is popularly called as octadecanol. Now in addition to these two chemicals, we can have bihenyl alcohol or a mixture of all of these chemicals, and they are found to be quite suitable. The chemicals that we are using, however, should be 99% pure for getting the desired properties of the monolayer. And National Chemical Laboratory Pune has developed one more compound by synthesizing the alkoxyethanol. So this is a developing process and we are getting new and new chemicals for the reduction in the evaporation process. But there are few factors which have to be kept in mind when we are using these chemicals. So they should possess the following properties. It should be tasteless, odorless, non-toxic, non-inflammable, and should not produce any effect on the quality of the water. Only then it can be used for the potable water. That means the water which is found to be suitable for drinking purposes. Only then we can use that water and we can use the chemicals on that. The chemical that we are using, that should easily spread and form an even, compact, cohesive and efficient monomolecular film on the water surface. The thin film that we are providing, that should be pervious to oxygen and carbon dioxide so that there is no restriction on the respiration process, but it should be tight enough so that it is not providing the escape to the water molecules. Also, this chemical film should be durable and should be able to reseal itself if there is any breakage during the operation because of the external disturbances such as the winds or the waves. And last factor is that it should not be adversely affected by the waterborne bacteria or proteins or other kind of impurities which are present in the water body. So that should be avoided. In addition to this, any kind of impact of the chemical should not be on the human body. That should also be kept in mind. Now, when we are using these chemicals, these are not found to be cost effective for the mass scale use, and also they are not found to be suitable when the following conditions are occurring. That means when the wind velocity, if that is exceeding 10 km per hour, for such huge amount of wind velocity, chemical treatment will not be a suitable measure. Second of the factor is that when the temperature is rising above 40 degrees Celsius, then in that case also this will not be having any impact, because in that case there might be some chemical reactions. And when the size of the water body is relatively large, so the amount of chemical that we will be requiring, that will be very high. So we avoid that for the mass scale use. Now, in addition to this, the other evaporation control measures like plantation of trees which act as the windbreakers, reduction of the exposed surface area by the using the different covers, underground storage, integrated operation, all of these are employed in some or the other parts of the country. But the effectiveness and the economy of these methods, it is yet to be established in comparison to these chemicals. So in India, the water conservation methods, they are presently being adopted mostly in the drought prone areas or where the water is not easily available. And therefore, the large scale use of such methods is not found to be economical or practically unfeasible because of their large size and adverse meteorological factors. That was the first type of the reservoir loss. The other type of the reservoir losses are the absorption losses and the percolation losses. So if the water is being absorbed by the boundaries or the banks of the reservoir, then that is the absorption loss. However, this do not play any significant role in the planning because their amount that is large in the beginning, but once the pores are completely filled up, when they are getting saturated, it falls down. Therefore, it depends upon the type of soil which is forming the reservoir or which is present in the surroundings of the reservoir. Now, for most of the reservoir, the banks are permeable, but the permeability is so low that the leakage is of no importance. And that is why both of these losses, that is the absorption and the percolation losses, they are of very lesser importance, or usually that is not considered when we are having the losses calculation. But in certain cases, when the badly fractured rocks are present or we are having the seams of the porous strata, in that case the serious leakage that may occur. And for that, what we do, we pressure grout that area so that we can seal the fractured rock. The cost of the grouting, that is also accounted in the economic studies of the project if the leakage is large, because when we are selecting the site for the reservoir, all of these factors are to be kept in mind, and if we are not considering that, so this treatment cost is to be included in the project cost. So that completes the discussion regarding the all type of the reservoir losses, and the most important one was the evaporation loss. So that completes the discussion regarding the water resource engineering first, Thank you.